Yeah, I did that, and then it showed the battery when it is completely dead. All right, good morning, folks. Today is Sunday, March 31st. So we are going to now move to a new topic, document AI. It represents sort of a midpoint in our bootcamp. We have so far been studying how we can use transformers, especially their generative abilities, to achieve very practical goals like semantic search, hybrid search, like RAG, the ability to do RAG. Then we went into a journey of multimodal learning. We did CLIP, followed it up with BLIP, BLIP2, and finally with Lava. And now we are coming back to a new topic. What that journey took us through is, in many ways, the practical side of perhaps the dominant generative AI use case, which is RAG. So RAG and AI search and hybrid search. These two things are, it's hard to find, like whenever you hear that companies are doing Gen AI internally, enterprises are doing, quite often they're doing some variation of this. Right? It's a no-brainer. It's a fairly safe thing to start. But today, we are going to move on to a new topic, document AI. See, let us put it in the context of RAG. Suppose you have a RAG system and you have search, you have a whole corpus of document. We enrich that document corpus with images, with audio, with video, potentially. We haven't done the audio video part, but we'll do it shortly. But it is a fact that a lot of documents exist in the paper form, isn't it? They are either as paper or they are just literally as photos. The pictures of those papers, they have been scanned and you get to have that, or you have a camera pointed at something and you have to figure out what is it. For example, a can of Coca-Cola will have the words Coca-Cola written at a slant along it, and there would be a lot of text, but it's written on a cylindrical surface, isn't it? Quite often, logos are written in a slant, right? And with all of these things, one real-world question that arises is, how can we incorporate all of that within our system? There are two ways. So the assumption here that you can sort of take for granted is, you do have access to a camera. The camera can bring you images. It can bring you images live, or you can take photographs and just generate a whole directory of images of the objects of interest. Are we together? So when we talk of documents, we mean more broadly. The way I'll use it will be more broadly. A document could be, for example, one of the most common things that happen in enterprises is you get receipts, right? It's hard to, if you're in any kind of a supply chain pipeline or logistics or things pipeline, you will notice a finance department, you ask them, they will tell you that, oh, it's a headache to deal with receipts. You also see that emerging companies that help you, for example, do expense reimbursement when you take your team out for lunch or something like that. And nowadays, what are some of the softwares called? I forgot. I used to use one of them when I was in corporate. Concur, Expensify, etc. Nowadays, they're giving you the ability to just point your cell phone at the receipt, and automatically it reads up what the restaurant is, what's the total amount, isn't it? And if you pause to think a little bit about it, most of the time, images taken from cell phone are pretty erratic. They are not properly oriented, right? They'll be skewed. There will be glare on them. They may even be crumpled, right? The restaurant or that shop might put their name, God knows where on the receipt, right? Total would be somewhere. And yet, the fact that we are able to decipher, you realize that it's a little bit like deciphering. It's when it comes to the machine, every receipt is almost like coming across an alien language, right? Or a different language, a forgotten language in which a content has been written. The only thing you know is exactly what will be on the receipt. Every receipt you assume will have a total amount, will have line items, will have hopefully the company's name, isn't it? So those are the things you come armed with. But at the end of it, you have to hunt for where they are on the receipt. The fact that we can do that with ease today, and we can do it even with a computer, with a very small computational capacity of a cell phone, isn't that amazing? Well, some of these, they take the image and they send it over to the central server in the cloud, where much more powerful models act upon it, right? And then the accuracies are much better. But today's content is that. And this field has a long and storied history. As you can imagine, as computers came by, for machine learning, people realized early on, just imagine in your mind the picture of a receipt or the picture of a text written on a billboard, whose picture you have, your photo you have at an angle, right? Or imagine that you're walking through a foreign country. Right? For example, my friend just visited mainland China, and all the trains are very efficient there. It makes you scratch your head and wonder, why don't we have such a train network? So he was visiting China and Japan and so forth. Now, they all apparently, they all obviously have excellent high-speed train systems. Now, there's one problem though. Everything is written in the local language, national languages. So imagine encountering everything in Chinese and then wondering which train should I catch. So what he would do is just point it to the symbol, and obviously Google would helpfully immediately translate it into English. And he was pretty independent. He spent 2 months in heavy technical discussions there, but in collaborations there. But at no point did he have to take help from a human. He was quite independent, just with the use of a cell phone that could do this, exactly the topic of today. Right? And when you see signs hanging from the ceiling, right, or some symbol on the wall, and you're pointing to it, you don't even know what it is. Do you see that? Right? So a machine needs to have the ability to tell apart a figure from text, baseline, right? So for example, do you notice that if you were to look at symbols all around here, sometimes there's no text available. Like for example, you look at these symbols in California, as you know, now all restaurants need to be all genders. So you see both gender restaurants. On this side, you see no smoking and symbol. So there is an icon and there is text. And sometimes if you look at the next one, the framed picture, which is a Plutarch saying that the education is the lighting of a fire, it's text in a picture frame. So what you need to do is, when you look at a picture, you need to first know where the text is, which part is the text, isn't it? That's the first thing. And then to decipher the text. And this field has been document AI, despite despite being a ubiquitous need everywhere, has actually notoriously been difficult. Even some of the oldest softwares and commercial softwares, like if you are using OCR, and I don't know, how many of you have experience with OCR? Right? How many of you would believe, who have experience with OCR, that it just works flawlessly?
What is OCR?
Okay, so we'll talk about that today. Right? Optical character recognition. It's like taking a book, scanning it, and having the text emerge from it. Right? So it is quite imperfect for quite a long time. It's getting better and better now. Okay? But the history of this field is that first thing people ask, can we program it? Right? And this question was asked, by the way, in the 1960s. Can we have a machine? Can we write code when there were mainframes? Can we write code and basically recognize the text? And the first successful optical character recognition was actually way back when in the 1960s. Today, it seems hard to believe that you could pull that off with vacuum tubes, a whole building full of vacuum tubes, isn't it? Right? And where core dump literally meant the electromagnetic core would dump the memory states. Right? And it has been, so there was success. The good news is that people knew and they succeeded using machines to do it as early as the 1960s. The bad news was that it was never flawless. For a very, very long time, it wasn't flawless. So as we do this work today, we are going to see, and I'll take you through in the first hour, through the various stages of, and in some sense, in a microcosm, it contains a little bit of the history of computer vision itself, the field of artificial intelligence called computer vision is very much, there's a story going through it of computer vision itself. So as algorithms came, so the first 101 question, can we program it? How many of you feel that you can write a deterministic program to, for example, recognize all the squiggly things that are written on this page? Recognize my handwriting. Can you write a if, else, and for loop to do that?
Well, in time, you have like 100 years eventually, because it's the variances that keep adding to the time.
Exactly. So there'll be almost near.
Sir, can you please share the screen?
Say that again.
Are you sharing your screen?
I am indeed.
Okay. I don't see your board.
Yeah.
Writing board.
Oh, no, it's not the writing board.
Oh,
it's just
okay.
the course portal
Thank
at this moment. So, just pick up your handwriting and ask yourself, can I write a C, Python, Java, whatever your favorite language is, program to recognize what's written here? You realize immediately that it is a quintessentially non-programmable task, right? There is no deterministic program that can understand what it is. It's the first recognition you need to have. Are we together? Because for every character, every letter, there are near infinite variations. You don't write A the way I write it. Right? You don't write Z the way I write it. So, and Z for those of you who are in Commonwealth countries, those of you who are in India at this moment, and attending from there. So, we do have to take recourse to machine learning. That's the first realization. And so as machine learning algorithms began to emerge, people began to apply it to this problem. The first task is, you need to take an image and you need to break it down into something that a machine learning algorithm will take. What do machine learning algorithms take as an input? A vector. That's all they take. Remember, guys, that a machine learning algorithm at the end of the day is, especially for a task like this, so recognizing a character and to tell whether it's which letter it is, or what would you call it? Which part of machine learning would it be? Classification, regression, clustering, what is it? Suppose I give you a character. Let's say I give you an image which has a character. Let's just say it has the character Q, right? And it needs to go into box, and out you have to tell which letter it is from A all the way to Z, which of the letters it is. Right. It is a classification problem, right? Classification problem. And so in a situation like this, what would you do? You have a machine that takes your input. What can the input look like? In machine learning, at the end of the day, all inputs must look like a vector, isn't it? No matter what, it has to look like a vector. And then will come out the probability vector, right? Probability of each of the objects, PA given X, or PB given X, PQ given X, and so forth. And what will be is this would be the max, right? This would be the max. So these things are the result of the softmax. For example, a softmax at the last layer, and then you would do this. So people were trying different algorithms as algorithms came out with different degrees of success. If you look at the history of this field, you'll realize that just about everything has to, every algorithm that you can imagine for classification has been tried on this problem. In fact, in one of the earlier incarnations of the Tuesday class, the introduction to AI, when we used to, so that course now we do in a very compacted 3-month frame because everybody seems to be in such a hurry to learn AI in one day, right? So there used to be a time when the material that's there in that 3-month course, we would actually do in a 9-month course. So one of the labs we used to do is take the same data set, the MNIST data set, and we would apply no less than 30 different classification algorithms to it, recreating the entire history of attempts that have been made since the 1960s on that problem. Right? And it was quite educational, quite illustrative to see how the field has evolved and where the algorithms stand with respect to each other, with respect to this problem. Right? Think of any classification algorithm and you can apply it, so long as you have a way to convert this into a vector, right? An image into a vector, which you can do simply by flattening, for example, isn't it? Now, coming back, OCR, the recognition of character in text. So suppose I give you a text, and now let me get more into the textual part of it. When actually, all right. So suppose you were to give you a text, the cow, you get a page and it has well, that's a very odd cow, right? So I'll try to do better. Let's say that there's a cow here, and we say the cow jumped over the moon. Now, you want to do optical character recognition. What are some of the things you need to do here? You need to read the text. You need to be able to create, you need to tell that this is, initially people thought, we need to be able to cut this out, right? Then we need to recognize where the texts are, isn't it? Within that also, we need to further break it up into do you see that? So broadly speaking, there were, so I won't go over anymore, but you get the idea. But do you notice the problem here? As I'm making those little boxes, those are called bounding boxes. What's the problem? No, that is one problem. There are lots of bounding boxes.
This is running handwriting, and
that is right. When I write running handwriting like jumping, right? First of all, I wrote it in such a squiggly way that unless you knew the word jumping, you wouldn't recognize it, right? So it's very difficult to break it up into individual characters. But the human eye, practiced in the language, immediately knows that the guy has written in a very sort of a cursive way, has written that the closest approximation is to the word jumping. In other words, we recognize at the level of words, not necessarily at the level of characters. In fact, if you look at this, this almost looks, this is an N, but you know that jumping is not a word, jumping is, right? And so from the surrounding context, you can essentially fix the mistake and say it is jumping, right? Go ahead.
So, given sufficient amount of training data, can we do it with the system? Given a picture and the text that comes out of it as a training data, given a large set of training data, can we do it
with the figure itself, with the picture itself?
I mean, basically using the clip algorithm, the clip model.
What is written there? So one question that I got, very nice question here from the audience here is, suppose you have a vast amount of training data, and can we directly, something somewhat like clip, look at this and say the text written on this is blah, right? So I would say, hold your breath. Let's see what comes, right? So, but anyway, I'm giving you the nuances of how this field is. And now in computer vision, there have been algorithms like predating neural networks. So see, there are two things. There are algorithms. How many of you, anybody here with a background in classical computer vision who knows? I'm going to put two magic words here. Does it mean anything to anyone here? Sift and hog. It doesn't. Okay, then we will forget about it. These are key points of feature. These are important things in computer vision theory. We won't. But so what people did is, before the neural networks came around, people used to think that, see, we need to feed in to the machine some vectors, isn't it? Given an image, so the problem was not even character recognition. So imagine an image. There is a cat. We want to figure out what is it, right? So the traditional way they thought is, hey, we need to feed to a function that can classify it some vectors or some sort of a vector representation of this. Obviously, just flattening it out is not a good job. It doesn't give you as good results, and we can try that. So they used all these techniques to find specific features in the image, right? So people would use hierarchy of Gaussians and so on and so forth. So they would come up with a process of feature extraction. Those features became input to machine learning algorithms. In particular, the last layer sometimes used to be, so you would do this pipeline and also old classic algos, CV algos, would produce features, feature vectors, which you would feed to, let's say, a classifier. And this classifier would say cat, right? Most likely a cat. Are you seeing that? Right? Now, these things, it's not that they're not effective, but the problem that we were facing is they were hitting a wall. It was very hard to get further improvement, right? So, and the accuracy was unacceptable. So historically, the first big change that came, which did not address the OCR per se, but addressed the big problem of drawing these bounding boxes. Right? The paper was the paper of RCNN. We are going to cover this paper quickly for historical reasons because it's the history of the field. Right? I have put it. So let me mention to you what we have on our course portal. And guys, this is a very practical area of machine learning, heavily used. Whatever project you're doing, I'm sure you will need to do this sooner or later. Are we together? So I would strongly encourage you to take this part of the bootcamp very, very seriously. Guys, if you're looking for a quick project to make money, whosoever you reach out to you for project, there is a reasonable probability that that guy will give you a huge bunch of documents of some kind and say, hey, could you put this information in the database? It could be medical bills, it could be invoices, it could be receipts, it could be driver licenses. Go ahead.
So in India, I know a lot of small businesses,
Mm-hmm.
which I know a lot of my friends and family have. All they maintain is handwritten.
Right.
And then they hire people
Yeah.
to convert that book to enter into like an Excel sheet or whatever. They have something called as tally in India. Right. So you think we can do that with this?
Not only will you be, so the audience question is in India, there are gazillions of companies that handwrite notes. And then they hire an army of style. Did you call them?
These are just like commerce graduates who are still in school. All they do is convert this book and
Yeah.
enter into
They do the
a software
data entry.
called as tally or Excel sheet.
Okay, and so they hire an army of underpaid, starving students, undergraduate students, to now translate this or do data entry. That business is traditionally called in the industry data entry, right? Data entry into some software. So the question is, what we are going to learn, can it replace that? What do you think? In fact, you better do that by end of this, right? That is your, I'll give you as a project, I'm giving you a much harder problem, much harder problem. And in fact, that's your next project. Right? So you'll see what that project is.
In some cases, you may not be able to decipher the document at all. So you have to be able to plan that.
Yeah. There, I mean, of course, you emit out the confidence intervals and so forth. That's true. Some things do need human intervention. So guys, here is your document AI section on the course portal. If you go back to your course portal, you will notice that we have been following, I don't know, when I look at how many of you are logging into the course portal, and by the way, I do look at those statistics. Right? I have a pretty good idea how much progress you're making with your projects and where you are in the learning. So if you haven't seen this portal, let me reintroduce you to it. Right. So this is a thing of all that you have learned. And guys, it is all there. Like, for example, last time we did lava. So here is your lava with all the papers and all the information associated with it, right? And today's topic is document AI. Read this introduction. So today we'll do the session backwards. What I'll do is I'll make you do some simple assignments, which is just reading some blogs and repeating the code, but doing it yourself in your Jupyter notebooks, in your Python scripts. Are we together? So you become reasonably familiar. Then I'll introduce you to the project. And then we will do the paper reading. We'll read a few research papers. So let me walk you through some of the research papers here. And first is the one. So one is Hugging Face blog. It's a good summary of everything. I would recommend that even before you do the assignment, just read this Hugging Face blog. Right? It's called Accelerating Document AI. It will be an eye-opener. If you haven't looked at where the state of the art is in document AI, this will be an eye-opener. Now, guys, I'll make a statement which is important. So pay attention to what I'm saying. There are commercial softwares that do document AI. Right? So why is it worthwhile for you to learn this? Anyone?
To learn how to utilize it?
To learn, no, they make it extremely easy. For example, GCP, if you use their document AI API or Azure or all these major cloud ones, Amazon, they will all very help, eagerly give you a document AI.
It is much more efficient.
What do you mean by efficient?
I mean, compared to the code is it's much faster.
You mean you
better.
can do better than Google? Anyone else?
The key reason is so that you can make a first-class citizen to your own software solution. Everyone else is just encapsulating what is relatively easy to do. And now you have this line item cost to what you're offering as value to any company you're trying to help.
That's right. That's right. So yeah, I guess you guys are coming to good reasons. Anyone else?
It can be used with a different area.
You can use it to different areas. Yes, partly correct. Anyone else?
We own the training data. And we can apply to our own domain. And
Absolutely.
train it better.
You can do
fine-tune
fine tuning.
easier.
Yes, you can fine tune it. Again, a good reason. Also, you own the model, so it's free, right? Except for the cost of hardware after that. And so all of you have collectively come upon the big reasons here. So I will say that to one of you, one of you answered that what we will build will be better than these big vendors. And I challenged you, do you think it will be? And then you got scared. You didn't want to stand your ground. But so now let's see what it is. See, guys, here's the thing. There are many aspects, there's a broad dimension to it. Just because these cloud providers give you the AI services, for example, today OpenAI is extremely inexpensive. You can get away. A lot of people are saying it's so cheap. Why do I need to hire a data science team or tune my own model? Guess what? Have you noticed that Amazon prices are no more half of what the retail prices used to be? Like if you go to a local Walmart or something, they are no more half of that. Anybody notice that Amazon now doesn't give you much of a discount? Right? But they used to. 20 years ago, they used to, isn't it?
Yeah.
Massive discount. So why do they not give discount?
People have forgotten to.
Because why should they? People are in the habit of going to Amazon. They give you other incentives. They say, hey, we'll do same-day delivery. Nobody can compete with that. They play on your psychology and they somehow, people are willing to pay the cost because somewhere they have internalized that Amazon is cheap. They don't need to be cheap. Right? It reminds me of something that to train animals at some point, right? You would use some string that would tie them to a certain area. They couldn't leave that area. Once they get completely conditioned to that, then you don't need that fence anymore. They wouldn't stray beyond that. Right. We have become like that. We have been conditioned to the belief that, by the way, not just Amazon, you can think of all these online retailers, that they were cheap, except that they are not cheap anymore. In fact, if you walk into your local retail store, sometimes you get it considerably cheaper, or at least at the same price, right? And so the same thing can happen to you. You are using this cloud services AI. Think about it this way. At this moment, the three cloud, a bunch of very big companies have a near industrial capture. They have all the GPUs. They're training all the big models. They can give you things at whatever price they want. It may not make any economic sense whatsoever, right? But why would they give it to you at that price?
Conditioning you.
Conditioning? No, because their competition is your in-house data science team. They want to condition you into the fact that they are cheaper than you hiring an in-house data science team, you buying hardware, and you training the model. Once you get conditioned, fast forward to 2035, you're paying through your nose because you have forgotten how to do it in-house. Have you guys seen, guys? I'll give you an illustration. By the way, this is a political statement, so please forgive my digression here. People here, people keep coming here and asking me at Support Vectors, why do you have on-premise hardware for AI? Right? And because they have been conditioned into the belief that cloud is cheaper. Is cloud cheaper? Anyone?
Depends on where you look at.
Where you look at it means?
It's meaning like if you want to hire GPU, don't go to AWS or otherwise look at it. Because I've been looking around vendors like Lambda, Runpod.
Yeah.
You could potentially
Be much
fine-tune
cheaper.
what you want,
Yes.
but 1/3, at least 2/3.
Yeah.
Amazon.
So first of all, the big guys, because they have the reputation, they are 3 times as expensive as the small guys. Runpod, for example, gives you 4090 at 70 cents an hour, as of yesterday that I remember. Now, even at that, is it cheaper? You keep running it. It's not. It's not at all. So I'll give you an example. Go to your favorite GCP, Amazon. Go there. Right? Reserve yourself a 192 core server, right, with 4 GPUs, right, with a net of 100 gigs of, let's say 100, 200 gigs of VRAMs.
It's a little house to get it.
Right. You will realize that they are charging you close to $200 an hour. Right. So how much does it cost a day? 4,800. How much does it cost you per month? 150,000. Yeah. The same server we have running here, we built it ourselves, right? Of course, we like to build things ourselves, not go running to a vendor to give us a machine. How much do you think it cost us?
75.
Yeah, 12,000 was the processor, was like market price. We got it at a discount, and the GPUs, etc. So all of it put together between 30 to 35K, right? So 1 month of use in the cloud is more expensive than running your own hardware. Why do they get away with it? Because, believe it or not, most software companies now are idiots. They have no ability to even install Linux on their. Just take a software developer. Just say, go install a Linux server, right? And install CUDA and all of that. And could you just run this model there?
But you have to add the OpEx as well, but it's not going to be insanely.
That's right. No, see, certainly it's true. There's an OpEx. You have to look at the employee cost and so on and so forth. But at the end of the day, the point is, you have to do a trade-off. You have to do a pros and cons analysis. To do a pros and cons analysis, you need at least 2 scenarios. These days, there is only one scenario in people's mind, which is that there's cloud. Let's do everything in the cloud.
The 2 scenarios like comparing the clouds.
Yeah, the 2 scenarios are just comparing the clouds. Yeah, it's like, should it be AWS or should it be Amazon or should it be Azure? Yeah.
So there is the question of an SLA, right? It's not just your OpEx, which fine you can get rid of.
Yeah.
Then yes, you have to pay your employees.
Yeah. So Vasanthi brought a good point that you have service level agreements and so on and so forth. So that point is there. See, the way I do it and the trade-off between cloud and in-house, I've always felt that development and QA, right, and demos should be done in-house. Production, of course, just put it in the cloud simply because, hey, the client is paying the bill, right? Is built into that licensing. And so for that situation, it might make more sense, but it sometimes might not. So if you look at companies like Walmart, by the way, who went all in for the cloud, they have retrenched. Now they are using a hybrid architecture. Some workloads they keep in the cloud, some they keep on the premise. So you have to do a pros and cons for all of that. So anyway, more broadly speaking.
One more point, right? Like, if you look at the big companies, Facebook, they're all on premise. They don't have any cloud.
Which one?
Facebook.
Facebook is all. Yeah, obviously the big guys are all in-house, of course.
They know it better.
They know it. Yeah. You can do optimizations, guys. The Moore's law.
Just like the same as Google for like GCP, right?
That's right. That's right. So, guys, let me bring it back now from the digression. The point to do, if you don't know how to run your own models, fine tune your own models, soon what will happen? As a population, as a professional group, you will lose you won't know anything about it. They can charge you whatever they want, right? See, we are seeing that in the United States, for example, as the geopolitical landscape is changing, we are suddenly very worried who will make our chips. All of our chips, it seems, are coming out of Taiwan, TSMC, isn't it? And when people are trying to recreate chip manufacturing in the country, do you know what the biggest problem is to chip manufacturing in the United States? What's the biggest problem? What is stopping us?
We don't have the labor force to actually do it with the skill set.
Absolutely. The main problem in the United States, as Sarah mentioned, who knows how to build a chip? We can't find that guy anywhere in the country, right? It's pretty bad, actually.
Is that true though? I mean, we have Intel, we have all those chip companies who do know.
No, they all were doing VLSI design and shipping the actual fabrication over to TSMC.
We lost that.
We lost it. We lost our foundries.
One interesting thing is like in colleges now the doubly degree is a lot of basically focus on doubly degree. It's just in the lower level semiconductor manufacturing.
Yeah.
A lot of funding is going there. People
Yeah.
That's one of the
So now
degrees.
we are busy trying to redevelop a lost skill.
Yeah.
Right. Yeah. I keep telling people that obviously I'm an old-fashioned thinker. I'm one of the last people who still remembers the log tables and can multiply and divide without a calculator, right? Or can do speed math. But don't lose the skills. You lose the skills. Anyway, that is one reason. But here is a bigger reason. That's a broader reason for everything. No AI, guys. Don't just outsource it to some guys who just made it cheap for you because tomorrow it won't be cheap. Right?
So can I share an example?
Yeah, sure. Go ahead.
So
Go ahead, sir.
we had one model that we were training, and our iterations were like a week and a half based on the hardware that we had. And we realized that, it costs us the exact same money. We just need to put a quantity against it, and we can get our iteration down to 6 hours and then adjust from there. So there are moments when, because in your in-house, you just don't have the equipment, but you can pay a given amount in order to reduce your iterations.
That's actually a very good counterpoint. Thank you, Sarah, for that. See, guys, cloud has elasticity. When you need that elasticity, it makes a lot of sense. Like, for example, all of us don't have access to A100 and H100, right? So anytime we need to train a model where these things would be good, or we need a lot of them, like we know that if we threw 10 of these, 12 of these, our job would run much faster. Then cloud that's where it shines, like it's incomparable because there's hardware there for you to pick up on a moment's notice.
So this argument is like true for even for the classical computing thing as well.
Everything, for everything.
Because if cloud is the way to go, then there won't be anything called VMware.
Right.
Right.
Yeah.
So it's still like people are hybrid.
People are doing hybrid, and see, people overstate the need for elasticity. Like as Sarah mentioned, she encountered a case where it was needed. But if you look at most people, business production runs at an even keel. There is a quantified expected load that doesn't change. And then there is a bit of stochastics on top of it, right? The even keel, 24/7 operational load, there it's a little harder to justify cloud, especially if you're doing very commodity things, right? With Kubernetes and all these things being very, very stable. See, when you are a small company and you can't afford an IT staff, there's an inflection point. It is cheaper to be in the cloud because these guys will come and demand 250,000 base salary, right? Each one of them. And if you hire only one of them, he'll hold the company hostage. So you go to the cloud.
Yeah.
The
So,
other
sir,
hand,
yeah. No, go. You're right, sir. So I just want to tell everybody that we have done tons of research. So don't waste your time trying to go to cloud to begin with. As Sarah said, when you are confident your code is production ready and you quickly want to go into the cloud and get out, you know that, okay, my code will be done training within 12 hours, then you do it. If you rent in the cloud and you forget about it, then you get ready for the big bill, like we used to for. So you can, one day I started the machine and did not turn it off, and next day I got a big credit card bill.
Oh yeah, there's a lot of morning aftershocks.
So when your code is ready, you know that if there is no bugs in it, go to cloud, train it, fine tune it, and then shut down the machine and get out of it.
That's right. That's right. Actually, I am like, whenever I have something running in the cloud, I can never sleep well because I keep
Yeah,
going.
that's true. That's true.
Yeah. All right, guys. So we'll come back to the point. So yeah, there are trade-offs. See, elasticity is a great thing. And when you are a small company and you can't afford a IT staff, it's certainly a great thing. But see, for many, many things, just elementary computer skills work that people are losing. Now, in the AI world also, guys, this document here, the reason I brought up this whole discussion, there was a reason for it. Document AI is one, and Vasanthi, you should have stood your ground, where what you do, and I hope you do right after this bootcamp, you will beat every single commercial tool hands down. Every single commercial tool hands down. How can I make that claim? Because documents come in a near infinity of shapes and sizes. They have a near infinite variety of structure, logos. You know, some will have a camel built on top of it. Some will have a watermark going across the page, right? They have close to 180 languages, right? And when you solve a problem, a practical problem, let's say that you're doing a practical problem, you're getting receipts or you're reading a driver's license or something like that, you're not solving for the whole world, right? You're solving a specific problem. Does that make sense? But this is where, you know, you always look, whenever you have a David and Goliath scenario, these Goliaths are there. They cannot actually solve they cannot custom build for an infinity of situations, isn't it? They have to make general purpose document AI machines, services. So does it stand to reason that if you build a model, they are reading from the same textbooks. They are also reading from the same, their engineers are also reading the same archive papers, isn't it? But they don't have the luxury of being able to fine tune to specific problems, isn't it? Therefore, one of the lessons that you will learn is by fine tuning a model, you get extraordinary gains in your document AI. Are we together? Tasks. So, which is why, in a way, right? See, when you do, if you go to like, in Wharton Business School, this is what I learned. If you do a business, first thing you ask is, what is my moat? How do I keep these barbarians out? Right? Here's a simple one. They just don't want to compete with you. Right? In your specific problem, they won't want to compete with you. So if you use that services, you can get certain level of accuracy. But if you build your own pipeline, you'll easily, with very little effort, you'll do much better. So I hope I've convinced you guys to do document AI, isn't it? Right? It's a worthy task. You can't say it's pointless. I can always use a cloud service.
While I was collecting documents for our project, I noticed a bunch of them were actually PDF slide sets with images and words. So is that a good area for document AI?
Absolutely, everything. Okay. If there is language in it on an image, even if you like, for example, I once was walking through in Benares, which is considered a very religion-oriented city. Some cows, like at some kids will just write something on the body of a cow, right? Hey Ram or something like that. You can take a picture of it and you'll see that our document AI better be able to read it. That's your homework. Are we together? So we'll learn about that. So guys, these are the crucial papers, and the way I've laid it out, they sort of capture, these papers they at least capture 10 years of history in this field, and 10 years in AI is a very long time, right? It captures a lot. So please do read the Hugging blog, and then there are certain resources you will refer to. There are certain tools. So there are certain open source tools, and obviously there are commercial tools. These are open source tools for OCR, optical character recognition, and so forth. Use it when you want to. Remember that these also you can fine tune. But what I will teach you is how to fine tune. Do you notice the word fine tune everywhere? Because you will not just use the tools. I want you to learn to fine tune and create custom models for specific tasks. Now, here is what I'll give you guys. I managed to find a database of fake and real passport images and another database of driver license images. So I'm going to give you guys a challenge. There'll be a prize. Whosoever does the best reading from that will get a specially annotated mug with support vectors written on it. Sorry, support vectors is too poor to offer anything better than that. So, well, okay, we'll make it really special. So, who is up to the challenge? I hope you all are. Right? You'll get a vast data set. You'll have to and walk through, write your code carefully. But today, I'm not going to read papers. I'm just going to, after this conversation about what document AI is, here's the thing you want to do. Read this Hugging Face blog. Read it. It will give you a general introduction and it will answer a lot of your questions. It's a vast field, guys. Huh? And I'm going to cover it in 2 weeks. So there is no way I can cover it. I like typically on document AI, when companies that are deep into documents, for them, I typically offer a 6-week workshop. And here we are trying to do it in 2 days. Right? So yet I've condensed it down to its bare essentials so that you will still get a lot out of it. All right. Read the Hugging Face. This is the history of it. The first one, RCNN used to just be able to find the objects in the, not actually do OCR, but find the objects. Right? I want you to actually go do these assignments. And then I'll explain the algorithms behind it carefully. Just go do these assignments, 3 assignments. And these assignments are not your project. Your project is different. I'll give you a Eclipse database. It is there, publicly available. Somebody has very helpfully created literally a gigs of fake and real, or so-called real passports. Right? And those passports are not nice, well boxes. So one is lying slant, one is lying on the table, one is lying, at a tilt, and so on and so forth. In one, the lighting is not okay. And your job and the challenge is there's a prize there. Let's see who can do the best extraction from that. Does that sound like fun? Yeah. So for that project, you get 2 weeks. All right, guys, so let's get started. There you are. We'll meet. I will, while you guys are working hard, I'll go and hardly work. I'll go for a nice walk and I'll see you guys. It's 11 o'clock. I'll see you guys in 2.5 hours. Is that reasonable? After lunch? Let's keep it quick. See, guys, do the assignment. If you guys find the assignments are too easy and this article is too easy, we can convene a little bit earlier. But I think it will take you each assignment, if I give it half an hour each, then it will take you minimum half an hour. and reading that article should properly will take you half an hour. So 2 hours, that makes it 1 o'clock. You will need to have lunch. Let's keep half an hour for lunch. So 2.5 hours. Does that sound reasonable, guys? We'll meet you at 1:30. 1:30. All right, guys. So we'll regroup at 1:30. I'm stopping the recording. Any questions before we start?
Should we read that before doing this?
Oh, yes. Read the entire introduction and read the Hugging Face blog and then do the assignments.
All right.
All three.
All three. Yes, yes. All three.
Which of them has to be done in my 30 minutes?
You will be able to do it. These are not hard, actually, because the code is there. You just have to, it's monkey see, monkey do, right? If you go here, why do I have to go through? Yeah, this is it. You see the code is there. You just have to repeat it in your Jupyter notebooks. Do repeat it. Now, if you get stuck, help each other, collaborate, form within your team, but get this to work. Right? And if you're not able to do all three, that's all right. You can do it after the paper readings. And if everybody is stuck and taking longer, we can extend the break. We can delay the paper readings. All right, guys. But it's a very interesting topic, and frankly, guys, very lucrative topic. If you don't know anything in machine learning, if the only thing you're capable of is document AI, and I know people who are capable of only one thing, right? You can still mint gold. Right? So take it very seriously, guys. I'll stop the recording.